when I look into energy storage, there's always two sides of the coin. One is really like the whole revenue and commercialization strategy, right? Like earning money with the storage assets. And the second one is to make that properly, you have to keep the technical performance to like high availability, high safety and reliability standards, all those kind of things. At TWAICE, we're really focusing on the second piece, on the technical performance of the assets.
Hello and welcome back to the Hypercube podcast. I'm delighted today to be joined by Stephan. Stephan, would you like to introduce yourself for the audience?
Yes. Hi, Adam. Thank you. It's a pleasure being here. I'm Stephan, like founder and CEO of TWAICE. And so it's an honor to have a conversation with you about like energy storage and analytics here today.
Yeah, very excited for this one. For those that maybe are less familiar, who are TWAICE and kind of what do you get up to?
So, I mean, like to give you a bit of an overview how the story started. So we started basically in 2014. I did my PhD in batteries. And what we basically did is we created a 200 kilowatt hour grid storage. It was called Energy Neighbor. It was placed here in Munich. So we did our PhD here and it supported a village. They had a lot of solar. So we created this battery storage, literally very hands-on, right? Like the housing, the cooling system, the battery management system, everything you could imagine we placed in there and did research about like how can this serve the local community, how can it earn money, but on the other hand also like how you can really like operate it in a safe and like high available manner. And that is actually like where we had the touch points with energy storage. And we realized then that during those years of doing research and building up the storage, that there is a lot of potential in optimizing this asset based on the data which comes out of the energy storage. In 2018, we finished our PhDs, energy storage project was done, and then we founded TWAICE. And our goal since 2018 is really like to plan, to help our customers to plan and operate energy storages with full confidence. And it started early. The industry came a long way. We came a long way, and now we're here.
Yeah, that is it, because 2014 feels like ancient history in this industry, like the way things have changed and what's gone on. Just to pick on a point there, so you're not just doing the optimization, but you're helping your customers plan their sites and their asset mix and things like that.
When I look into energy storage, there's always two sides of the coin. One is really like the whole revenue and commercialization strategy, right? Like earning money with the storage assets. And the second one is to make that properly, you have to keep the technical performance to high availability, high safety and reliability standards, all those kind of things. At TWAICE, we're really focusing on the second piece, on the technical performance of the assets. As that for us always has two parts. One is like the planning of the energy storage projects, asset, choosing the right suppliers, all of those kind of things, choosing the right cell. So that's like the planning phase. And the second one is when operating that and monitoring and analyzing it and try to be as proactive and predictive as possible. And your question comes to like the planning phase. And you're right. I think personally, a lot of right and wrong decisions are made in the planning phase, right? Which supplier you're choosing, right? A lot of availability of the assets choosing the right suppliers, for example. And there we are supporting our customers with, for example, supplier selection, comparing different cell chemistry. I mean, the original storage we created in 2014 was actually an LFP cell. So it was very early already. That be like a very strong dominance of LFP batteries. But overall, right, it's like really also helping them to do different degradation simulation, different cell selection during the planning phase. And then hopefully they have created a successful project, made it through the grid connection queue, got the project live, and then it's about like optimizing it afterwards.
Yeah, that is interesting. And so we're right into the weeds here, but we're off piece with the questions, but it's fine. Anecdotally, I feel like in my experience, there's a lot of people, especially in the GB market, there's a lot of new players, people that have come into the industry. They've seen the high revenues of a few years ago. They've got moving with the project, seen that they may be simpler than other capital infrastructure projects, and started to move, and maybe aren't as familiar with some of the technical complexities, especially around the data and things like that where we live. This industry bears needs. Do you find that you have to do a lot of education on that journey? Because it feels like you're really well placed to do so, right?
Yes, so you're absolutely right. I mean, what we see similar, like in UK market, but also like in a lot of other areas, is the good news about energy storage assets is now that you can build a business out of it, right? You make money, you can earn money, the projects are viable. But in some cases, honestly, even like when you look at the ERCOT or so, they are even more profitable than, for example, solar projects. And that basically leads exactly what you described, is that a lot of infrastructure investors, which maybe like invested before in solar and wind, now doing the same on the energy storage side. So they're moving into the space, building up large pipelines, large projects. But having said so, batteries are by nature very different to solar panels or wind, because it's at the end, it's an electrochemical system, right? Like you have a lot of different cell chemistries in those storages, like the cooling, like the connection, like the energy management system. Then it's only not a producing element, but also like a consuming. So charge and discharge. So highly flexible, quite complex asset. And for most of the companies, or a lot of them treating very similar to solar, right? Like making the business cases, getting the ARR out of it and starting of it. And you're up to right. There's like a lot of education needed. The whole industry is so new still that the question is, where do you bring out your experience, right? I mean, we did it since 2014, but honestly speaking, until 2019, 20, there were not too many energy storages out there. So how can you build up like experience about different suppliers, about different how you build up the storage if you go like with DC blocks or like on the AC side. So there's like a lot of different choices you should and can make. And you're absolutely right. There's like a lot of educational part to it. And due to that, we also think it's crucial, and it was like what makes us unique, that we already start in the planning phase and not only covering the operational phase, because we have seen that in the past with a lot of customers. When you make the wrong choices there, then you have to work hard afterwards to get really high performing, high available assets afterwards. So yes, there's a lot of education needed.
And I guess no one's been doing this for 15 years yet, right? Because it is that young as an industry, like the tail end, the kind of late life problems we've not even really seen for many of these assets. We can see what we expect, but it's an interesting place to play. Something I'd be interested to know from you then, like from you, the customers you speak to, the projects you've been involved with. Do you have an idea of the biggest trends within BESS and the market today, and some of the big changes perhaps over the last few years?
So, like there, I can speak probably for an hour about it, but I think the biggest trends overall, and also like then pain points from our customers in a second step. So the trends are in general, cost from batteries are coming down, right? So we see that like a lot of shift to LFP batteries, which make most of like the batteries out there now on the BESS side. Then there's also like a lot of cost optimization happening, that a lot of like players source DC blocks from like Asian suppliers, which makes it easier to augment. They select an inverter, modularizing it, and bring in also like a lot of like efficiency in building up the projects. And then we see some trends on like on the DC side, that a lot of companies now starting also like co-locating storage with like solar assets. And so there is like a good trend in using like really DC coupled energy storages with solar. So there's like a lot of innovation or trends coming out which are independent from the cell chemistry. And it's more like how you build and design the projects. I think that's one big part of it. And the second one is really like the viability of the business cases. So when you look in the market right now, it's And I think that's great to see, right? I mean, when you are in 2014, it was always how hypothetically you can earn money with energy storage assets. Now there are so many different trends of like in capacity markets, in energy shifting, in frequency control, in also like replacing some transmission lines with like non-wired assets. So there's like a lot of potential in earning revenue. And that is also like a big trend across the globe, like UK market, Europe, Central Europe, and the US and Australia. And that leads that like more energy storage assets are getting deployed. Now, when we look at TWAICE right now, and we just did like a survey, it's exactly how you described before. Like a lot of new players are coming in, building up like then first energy storage assets, and then they are struggling, right? And that is like the most dominant one is because the asset is not at the availability as they have planned. We just like the survey, which we're launching this week, and around like we did like a survey of around 100 BESS experts who run and operate BESS, and 58% say like availability is a major problem. Because when you like imagine you run like you have planned your business case 95% of availability or 97%, it's only 95%. Then you, of course, on the one hand side, you have like the revenue models, you can earn money out of it, but when the availability doesn't fit together, then that's a big pain point. Or on the other hand, you also like running some penalties, SOC is not accurate. Like a lot of those areas where I would say now the next couple of years, 1, 2, 3 years, it's a lot about the trend of really like the industry learning curve of really deploying and running highly available assets out there. So I would say that's another piece and a very linked to TWAICE.
Yeah, that's really cool. And so just, is it like that the availability is just lower than expected, or is the availability hard to predict and more unpredictable, like difficult to forecast, so making it difficult? Was it both?
Yeah, it's you're right. So at the end, it's both, right? Our belief is that the data strategy of an energy storage is a very big part of your commercial strategy. Because you need like these assets, like you have like hundreds of thousands or even like millions in large assets in the US, for example, or Australia, of battery cells in there. Mm-hmm. These are generating a massive amount of data. Then you have like the cooling system, you have the inverter, like the PCS, all of that generating a massive amount of data. And one is to really getting from like more like this looking backwards to like a predictability. So really understanding, now you get into the hot season in the ERCOT in the US, your storage has to be live because there is where the big spreads are in the market. That is where you earn money in a couple of days. So to make really sure you have a high performing asset going forward. So it's really drawing conclusions out of the data on will there be some imbalances coming? Are there some trends building up in the assets or not? I think that's one big part. But even more important, or like similar important, is when you realize you have some availability issues, where does it actually come from? And secondly, what can you do around it to really like rebalance the system, recover some parts of the lost energy of the assets, and doing really like the root cause analysis in the right action. Because as you mentioned, you have like a lot of containers, a lot of components in there, and to really pinpoint that is not easy. And now like let's zoom out, or let's zoom forward. In a couple of years from now, every operation manager or like asset manager, they are not responsible for one storage asset. Maybe they are responsible for 10, 15 storage assets. Mm-hmm. And then the scale just increases. And when you don't have like an optimized system in place, which really helps to understand the assets at scale, and like finding the root cause analysis, helping you to predict when things can go wrong in the future, and really helping you to optimize in an optimized fashion, increase availability, then you could be lost.
Yeah, like, is it even possible without the granular, the large data? Like, how would you even go about like doing that analysis without holding all the data and churning through it? It feels like just one of those problems that there is only a complex solution to.
You're probably right. There's like there is no easy answer to that. I mean, what you can see in the market is that, of course, some of the integrators who deploying the assets are very vertically integrated and maybe take all the risk on their side, so that the asset owner or like operator has to worry less about it. At a certain moment, they have to worry because there is always like a time frame to it, and usually energy storage assets should run for quite a long time. So there is maybe like on a business model side some things you could do around it. But when you really like not sourcing only for one supplier, but several suppliers, or maybe also more to get some cheaper solutions, and sourcing from maybe like more lower expensive integrators, then there is no way to like bring in some burden in-house. And there's also like a big belief in, and also like I think that's right, that when you not only own the storages, but and really operate them also on the commercial side, and build up a good data and maintenance strategy and operation strategy, that you have just like higher availability and higher earning assets. And that at the end helps you again, right, to get more money in building next projects. So it's probably the complex and more difficult way, but it's also probably the more profitable or more lucrative way.
Yeah, it's like an investment in your future revenue certainty and lifetime of the asset, I guess, as well, like geeking out more performance and more lifetime. Not a job for Excel, though. We're not doing it in emails and Excel, I imagine.
Hopefully not. Yes, exactly. No. So, I mean, at the end, it's like we see that that a lot of like companies who more coming from maybe like solar and wind monitoring, even they are like just blown away how much data an energy storage asset generates. And then usually like the data, like the energy storage assets like providing from the battery management system or the SCADA system transferred is usually, I mean, it's temperature, current, voltage. I mean, there is some information in it, but it's at the end, it's not like the most smartest data. So you have to first do something with the data to understand what is like the SOC imbalance, what is the thermal imbalance, is there some KPIs building up which are safety critical, all those kind of information. And then you have to do it in an optimized way, because like when you're like an O&M person, you don't want to do like a once a month manual analysis. You want to have it when you want to have it, right? So in the next hour, because you do the reporting for this week and so on. And I think that is like one big piece. And to share like also like one use case where we see also like this interplay is when you invest like in 100 megawatt hour storage, then it costs you 30-40 million, and like the large ones are in the hundreds of millions. So there's like a big asset value going for the integrator to the asset owner. And especially like this handover phase, which you call like the commissioning phase, where like the energy storage gets energized and generates the first data and like the first cycling. And you can use this initial data already heavily to de-risk the energy storage assets, right? Because in this handover phase, you really want to make sure and check, did I really get what I have bought, right? And there is like the first time where you get real live data from the energy storage assets, and consuming that and drawing the right conclusions out of it is often a very cheap way of de-risking the assets. And for us, in every commissioning phase we're in there, we have found things which otherwise the asset owner would not found. And now going one step back, when you decide as an asset owner to go with like a very verticalized integrated integrator, you get any data. How can you really double check that you got what you have really like bought and ordered? So there's like a piece to it. So there's probably no other way to take some burden on those topics to your side. Otherwise you also can't double check it.
And that's it. And we find that from the kind of operations point of view as well, around like asset owners that maybe use route to market providers or optimizers, where they're handing over the control of the asset. And we get this common complaint that how do they verify the performance of the asset? How do they verify the decisions made by the optimizer against the portfolio? Was my asset optimized for my returns or the portfolio's returns, which will have other companies' assets in it and things like that? And it's actually a really hard question to answer unless you do have, and again, it's one of those problems. It's like, well, the only way to answer the question is to just get all of the data and do it all yourself, which is quite a painful point. What about, do you ever get asked about like simulated batteries and digital twins then? Because you must have, like, you've built up a business now, you've seen lots of different assets, you've got lots of battery boffins like yourself that really know the domain, right? Have you looked, do you get asked that about simulations and digital twins? And is that an offering that TWAICE can put forward?
Yes, you're absolutely right. I mean, we have like seen now a quite decent amount of energy storage assets across the globe and different cell chemistries. And what we are doing now is, I mean, at the end, it's like a lot of like expert knowledge, right? And the question is, how can you make this expert knowledge available? And for us, it's again the same statement, right? Like we are there to really like plan and operate the BESS with full confidence. And so you can use like this expert knowledge in the plan phase. So where we provide some simulation tools to our customers where they can like simulate different degradation for different cells, can really like also, they are usually sourcing a lot of new suppliers, so can double check is really like performing how the cell suppliers originally claimed. So there's like a lot of potential into also like do the benchmarking in this plan phase. But having said so, then of course in the operational phase, bring in the expert knowledge of, and that's a lot about, I would say, about a lot of value comes from like a company like TWAICE, and analytics is also to find the things the customers don't know yet. And a lot of those things come from understanding how maybe also other assets are performing and behaving. I brought this example of availability before, but there's also a lot of like value proposition around safety and around warranty tracking. And on the safety side, at the end, there are for us always two major things. One is a trend, right? Like a battery gets like worse over time and you see the trend, and then you can see like how this cell performs to another cell and what is like, are there different trends, and then you can spot it and can detect it. But there's also another area, and that is like more like the outliers, and they are there actually from the beginning. So when you switch on your assets and you have some quality issues in your cells, which can be safety critical later on, you can detect them in the first week of operations. But they can cause fires in 2 years from now. But these come from having like the database and expert knowledge to really like see, are there some outlier behaviors in the assets and spot them in some optimized way. So, and so due to that, like, yes, you're right. Like we are using this expert knowledge in the planning phase, but also the operational phase, which is then more linked to like safety, but also some kind of warranties, right? Because when you, and then it comes again to the same thing you have mentioned before, right? Like is on a commercialization or trader side, so they're taking over the assets. And then there's always the question is, I mean, what was happening with the assets? Because like integrated provides a warranty, then there is an owner, then there is like an operator. And at the end, like are the warranties voided? Is the storage behaving like the warranties? And the warranty is often not only like degradation over time, it's like round trip efficiency, different temperature conditions. There's like a lot of like boundaries to it. And the question is, do you only interest in the status quo, or also like how does the next 1, 2, 3 years look like? And that is quite, and due to that, using this expert knowledge, also like doing some prediction of, for example, is like this asset degrading, how is the asset degrading over the next couple of years? And is there an impact to the warranties? Of course, can help you to make different decisions on the commercialization side.
So we've skirted around it a fair bit. I'm really interested in that early warning, early indicator of things in the first few weeks of operation that show you there are outliers here. That's one of the main benefits, I think, of utilizing third parties that are separated from like your engagement in any business domain, like TWAICE or like a company like Hypercube or others. We see like 1 in a million events quite a lot more often because we have more exposure to more systems, and that's some of the value that I think you bring to bear as a third party. So it's interesting that you're already looking at like early indicators for lifetime issues and things. I think that's a really valuable additional benefit to using a platform like TWAICE. And so we've skirted around the issue a bit, or the topic a bit, but you must be such a fascinating place to work for data scientists, machine learning people. Have you got loads of really super clever, really happy stats boffins under the hood somewhere?
Yeah, so I hope so. So no, you're absolutely right. I think in general for us, we always have the three domain, right? Like one is really like the battery expertise. So the domain about batteries is also where I come from, like battery PhDs. Then you have like this big the crowd of like the data scientists, because at the end it's all about data.
Yeah.
And the third one is of course bring that into a usable software or service which customers which brings value to our customers. And you're right, there's like a lot of playground around on the data because, and I think we will see that even more going forward because I would say when you look 4 years back, there was I mean at the end there were not too many energy storages out there. Now it started really like picking up. And now like 2, 3, 4 years back, there was also like small pilot storages. At the end, it was for testing reasons, right? And then now the last 2, 3 years, companies scaling really in for scale. And for scale means you need to bring in some data strategy, right? And I think we are just like one company of pioneering of what the value can be out of it. You touched about it, that like early detections, safety side, availability, warranty track. There are a lot of different use cases which bring value, but there's also a lot of use cases on the commercialization and revenue training side, which bring value because you have like a lot of data around the assets, but also around weather, like forecasts and all those kind of things. And so due to that, the data scientist is a very crucial piece. But my learning over the last couple of years is, at the end, you really need to tie all the three disciplines very much together. Because at the end, as a customer, nice insights are good, but can you really use them? Or they are understandable? Can you do some reporting out of it? Can you share this reporting with your colleague? All of those kind of things. And so you have to like somehow merge this expert knowledge and data scientists in really like a software which is industrial scale and can be used. Otherwise, you're more like a reporting platform, which is fair for the learning phase of a lot of these. But is it really like the professional solution where you want to run your 5 gigawatt hours on, like hundreds of millions of asset value, like
And yeah, it's almost like you've read our pitch deck, but that's totally like my spiel around the value that Hypercube, I think, brings. It's learning a domain takes a long time, and you point techies at any problem and they'll find interesting things. They'll find patterns. They'll find crevices with stuff to look at that holds promise. But it's only really when you connect the dots to someone that deeply understands the commercial side of the opportunity, the business, the strategy, and the domain that you're in, that the magic starts to happen. And it takes a long time to bring all that together and build a culture that does that. And it was like, well, at Hypercube, we were going to obsess about one domain like really deeply and hopefully bring the expertise to bear on our problems. And it makes a big difference. So like you can get going much faster. You can challenge the customer on assumptions and things, because you can say, well, actually, no, we've done this before. We've seen this elsewhere. We do understand what you're trying to achieve and where that goes. We've talked a lot about battery and the energy trend. I'm interested, what about like technology trends? There's a lot going on. Obviously, everyone's dead excited about AI at the moment. Are there technology trends in the kind of software space that are interesting for TWAICE and what you're doing?
I mean, when you look at TWAICE, the name, we used AI since 2018. So we went into that space very early. It was more called machine learning during that time. But now I would say it's really turning more in a faster, more efficient way insights out of the data. And secondly, it's about making it understandable, right? Because at the end, like it's we always have to imagine when the industry is scaling up, of course, there's like more energy storage experts and battery experts are entering the field and like deploying, running the assets. But it's not a secret that like a lot of companies, when you look in Germany right now, I think we have 2 gigawatt hours live and 200 gigawatt hours in the grid queue. So when you imagine that, it's just crazy. So somehow, even like we will not get there probably, but just getting a bit close in that direction, you have to deploy and run so many energy storage assets, which is crazy. So you need to have a lot of experts and a lot of like people doing so. And I think a lot of power comes, AI is bring in this expert knowledge to people who maybe are did not their 5 years of battery PhD. And so I think that's quite exciting, quite exciting technology, which we also like adopt and use way more. And second one is, I think also like making this whole knowledge way more transferable, because when you see a lot of different cell chemistries, different assets and so on, I think that is quite interesting. And maybe like bringing in a completely different one is like on the trading side. I think there's also like where you folks are thinking a lot about it, right? Like to really have some like more AI-enabled energy or like dispatching of the storage assets. I think there's like a lot of power in that area of the coin. And it goes back to, and maybe like that's like originally, because I'm a battery expert, when you look at cell chemistries, right? Like now we have like LFP cells, but there's so many companies out there who do research on material level, how to design the next battery cell and make that more performant, more safer, higher energy density. And they also adopt a lot of AI to define the material discovery. So I would say it's really like a horizontal technology, which probably addresses most of like the parts of like the whole supply and value chain of an energy storage asset. So that's quite cool.
Yeah, and we've built solutions across all that space. It's quite funny because I think people naturally jump to like AI is going to be completely automated, it's going to take control, it's going to take over, and they get fearful of that. And I wouldn't be very comfortable handing over my €100 million battery to some AI model, right? But actually, there's so much value in that, processing the million cells of data that's streaming 20 hertz of logs at you and not stopping, and processing that and turning it into a lens that's human understandable. Actually, I think that's where all the low-hanging fruit in the AI space is going to come from in the interim. And it sounds like that's the kind of work you're doing over at TWAICE. Would you say that the appetite for new technologies is there with the customers, with the owners, or in our experience, we find that it's maybe a little bit conservative, a little bit reticent to do things safely and that kind of low risk approach?
So that's a very fair question and a very, very valid one. So, I mean, when you look at the energy storage industries, then the players can be quite different, right? It can be like utility companies. We are moving into the space right now. So more like coming from gas and coal, and like big utilities now deploying and operating energy storage assets in, for example, capacity markets. Then you have like the IPPs, maybe also like really like self-integrated IPPs who only do energy storage asset for the last 4 or 5 years and really innovating that area. And then there's like a third one, which are more like this infrastructure investments, companies, project development who did solar, wind, and now like also running into energy storage assets. And I think, and probably there's like a lot of different others as well. And I would say there is like different players have a different sense or appetite for innovation and risk. So when you look at utility companies, for example, at TWAICE, we did all like the certification, ISO, cybersecurity, all what you can imagine, because it's such a regulated industry. And to move into this regulated industry, you are absolutely right. It's about bringing the value, but the value have to come with a lot of security. So whereas like smaller company, 30 people building like the 5th or 6th energy storage asset and really just pioneering that area, and and maybe even like really like own, also operate the assets and so on. So they are way more open to also like apply new technology, maybe get a bit more risk in as well. So I would say it really depends on which kind of player looking into that. And the nice thing and exciting thing in the energy storage side is you see them all now. So yeah, actually.
And so talked about 200 gigawatt hours of pipeline in Germany. You've got, the goings on you've got ERCOT, Kaizo, the GB market, Australia, all on the up. Do you think the manufacturing and the kind of, even the bureaucratic capacity is there to make all this happen? Or are we already at a point where we need technological breakthroughs to achieve some of this stuff from a BESS perspective, I guess?
So I would say that we're definitely not there yet, right? Because I think we have a lot of trends which help us to get there, right? Like this reducing battery costs in a lot of areas. The energy storage are earning money. But having said so, there is still a lot of regulation needed depending on which country you are in, right? But for example, when you look UK, US, Europe, and Australia, right? Like in UK and Australia, I mean, those countries are, I mean, you know that best in UK market, right? It's just like growing strongly because in Germany, for example, you have like a lot of like this pumped hydro storage. In the US, like you have like more gas to fill up the peak demand. And that's less there in UK and less there in the Australian market. So was a bigger need also from a regulatory perspective to make it available, deploying storage to really like stabilize the grid. And I think same things are possible in markets like Germany or in some. I think in the US, you always have to differentiate Kaizo, ERCOT. They are moving faster, other areas not. So it depends. So, but there's a lot of regulation possible. And when you, like in Germany, for example, when you apply for like grid connection, right, you don't know where you are there, in which queue, and like you have less transparency. And I would say it's really about this regulation, but also really like the market design, transparency on those topics are very much needed to just like really get like the energy storage industry even further accelerated. I think honestly speaking, it's less about the technology breakthroughs, right? I think the current battery technologies which are out there, lithium-ion, LFP cells, and like the moving to DC block, like a lot of those trends are good for the current serving of the current use cases, like 1 to 4 hour systems. When we think about longer duration, 8-hour system, it's also possible, but therefore the costs have to come even further down, maybe to 50 euros per kilowatt hour. And I think then it also gets viable in these use cases, but we are not there. There are some like examples, but we are not there in a lot of countries.
And what do you think for BESS, like long duration storage then? What do you think are the biggest challenges to scaling that?
So I think the biggest challenge still is that when you have the choice of investing in 2-hour system or 4-hour system, mostly, I mean, 95% I think are still 1 to 4 hour systems, and most of it 2-hour systems. So you have to make an investment decision, and you see like the 2-hour system are way more profitable because it's just like the spread in the day. You can cover a lot of like the profits with like a 2-hour system, for example. Then it doesn't make sense for you to invest into a long duration storage asset. So either you subsidize it somehow, which often is not the right way, or on the other hand, you have to do some like market regulation that, for example, like this backup power or like the capacity for 8 hours is more rewarded. But probably the biggest barrier still are the costs, because when you look at an 8-hour system, it's probably 2 to 4 times the capex. which you actually usually invest to. So the prices have to come down probably on the lithium iron side to 50 euros per kilowatt hours and below, that you can really see like large deployments of 8-hour system of lithium ion batteries. I mean, there are some technologies out there like sodium ion or iron air, which have the promise of maybe moving in that direction. And then you will also see that in long duration assets. But I would say right now it's really like the competition that the others are just more economically feasible. So as long as those markets are not saturated yet and you can earn money in those areas, you will always try first to bring those projects live, I would say. But we'll see a difference in 4 or 5 years from now. Or maybe even faster.
Have you got any like hot takes or anything controversial about the industry or future predictions that we could get the inside scoop on?
So for now, I would say it's not a controversy, but I think most of the people still very much understand and underestimate how crucial availability of assets is, and really bring the assets to highly available portfolios, and covering this SOC imbalances, thermal imbalances, all of those kind of things is hard work. And I would say it's also one of the big themes still for this whole year. And so we'll see. We are doing a lot in this area with like performance management, but we also see like we will see a lot more in the industry, because every percentage you're losing, you lose revenue, right? And you need to make sure that you squeeze the most out of your assets.
And if someone like falls in love with TWAICE, listening to this podcast, and was looking to kind of apply, what kind of people do you look for, or skills you on the hunt for?
When you're interested in energy storage, but more like commercial minded, right? Like, let's talk to us. On the other hand, also you know that like battery expertise, data scientists, software engineers, and we are currently as a company operating across Europe, in the US, and also have first projects in Australia. The time zone.
That's so fun for you.
Exactly. You should be okay with some time zone shifts.
Yeah. So you're not allowed to like sleeping.
Yeah, exactly.
Very cool. Well, before I let anyone go, I always like to ask is if people want to learn more about you, TWAICE, what you're doing, or if there's anything you'd like to promote or plug, where should we direct them?
So, I mean, a lot of events are coming up the next couple of months. There's like Energy Storage Summit in London. There's a Smarter E in Munich. Apart from that, like on our website, and we're just launching this week, hopefully today or tomorrow, like our big survey where we did like interviewed around 100 of BESS experts and their main priorities on tools, on data, and all of those kind of things. And that's a quite interesting piece. So it's definitely worth to watch out either on our website or some news now. It will be a good piece to really think through how you want to build up your tooling and your infrastructure and data strategy going forward when you see it up.
Amazing. Well, look, it's been an absolute pleasure, Stephan. I'm sure we could nerd out about batteries in the BESS industry for quite a few more hours, but it's been a pleasure to have you on today. And yeah, wish you all the best with the lack of sleep and global expansion of TWAICE.
Thank you. The pleasure was all mine, Adam. Great talking to you.
Brilliant conversation there with Stephan from TWAICE. Some of the stuff they are up to is really interesting. That piece around being able to simulate batteries and understand the longer term planning is really, really interesting, and something a lot of the people we speak to struggle with, I think, and they're interested in. The fact that, again, the value of going to like a third party that sees lots of different case studies and being able to identify like once in a million events and bring that experience to bear on your project is really, really cool. And it lends itself to powerful forecasting models and like outlier detection, really clever solutions. Pleased to hear Stephan cement the fact that all of this domain really relies on a really strong data strategy, good foundations, like getting the technology right. These kinds of assets, BESS assets, are just so data hungry and technically a lot more complex than a lot of other asset classes. So it's interesting to hear him reflect some of that experience that we had across the board. Altogether, look, fascinating company, really exciting journey they've been on, and one that I'll definitely be keeping an eye on as they expand out to the US and Australia. So yeah, great episode.